So let us study about gamma and beta functions today in detail. So this video would be about the theory of it. And now repeatedly we can see that in JEE exams, gamma and beta functions are used extensively. Although they are not going to give you direct applications of this and do not really expect you to know the theory. But what they are going to do is they're simply going to provide the definition there and there, and then give an integration or some kind of a problem involving that. But it is much better to know it yourself so that you do not really have to rely on this extra information given in the questions, and you can directly identify what are they. So what is a gamma function? First of all, it is denoted by the symbol like this. This is the gamma symbol, actually the capital gamma symbol. And you know the small hand gamma looks like this, correct? These are both Greek letters. Now, how is it defined? Gamma is defined like this. Gamma of s is an integral basically, which is 0 to infinity x to the power s minus 1 e to the power of minus x dx. So everything is very important here. The limit must be 0 to infinity x to the power s minus 1 and not s and e to the power minus x dx. This is the definition of gamma, and obviously s must be greater than 0 here, and s is real. We are only talking about real numbers right now. This is the definition of gamma function. First of all, according to this definition, a few properties can directly be found out using this. Number one, gamma of s is equals to s minus 1 factorial for s belongs to natural numbers. This can be found out immediately. Number two, you can find out using reduction techniques. Number two, something which is used in finding this is this, that gamma of s plus 1 is s into gamma of s. Okay. This is called the reduction technique. You can reduce values of gamma like this. Number three, something you won't be able to find using real analysis is gamma of half is equals to root pi. Okay, you need complex analysis for finding this result. So gamma of half is equals to root pi is a very special value. Now, how do you actually find out values of gamma? So, of course, you notice that any integer valued gamma function can easily be evaluated to a factorial form, and that any half integer valued gamma function can also be evaluated to some form of fraction multiplied by some root pi. A few examples would be like this. If you want to find gamma of 5, this should be nothing but 4 factorial, right? Which is 24. Gamma of 1 should be 0 factorial, which is 1. Gamma of 3 by 2. And now you do the reduction technique of gamma of s plus 1. You write it as gamma of 1 plus 1 by 2, and simply write then it as the half into gamma of half, correct? And now therefore this becomes root pi by, okay. Another important formula and the last property we are going to learn is Euler's reflection formula. Euler's reflection formula. And what does it state us? It states that for 0 less than s less than 1, we have, of course, s is a real number, gamma of s multiplied by gamma of 1 minus s is equals to pi by sine of pi s. And of course, if you want to put the value here of, let's say, s equals to half, you can also find out by putting s equals to half, you get gamma of half equals to only pi gamma of half whole square, which means gamma of half is root pi. So yeah, this is Euler's reflection formula. Again, this cannot be really proved using real analysis directly. You need to have knowledge of residue theorems and complex analysis and contour integration in order to find out this. So that is completely out of topic. You only need to understand the result here and how to use it perfectly. So this summarizes the gamma function. There could be a lot of integrals regarding this, but yeah, this is the gist of it. Next comes the beta function. Okay, and now the beta function comes later on because it is defined in terms of gamma function when we are finding out the result. So again, beta of a comma b, it has two parameters, and it is defined as the integral 0 to 1 x to the power a minus 1 and then 1 minus x whole to the power b minus 1 dx, correct? So this is the beta function, and there is another definition to it, which is the improper integral version of this, which is 0 to infinity x to the power of a minus 1 divided by 1 plus x whole to the power a plus b dx. This is the same as this integral. They can be transformed into one another using a proper substitution. And similarly, 0 to infinity, x to the power b minus 1 by 1 plus x whole to the power a plus b dx. All of this are beta integrals only. Again, as usual, a greater than 0 and b greater than 0 has to be followed. Why? Since the beta function's value, the value of this integral depends on the gamma function like this. Gamma of a, gamma of b divided by gamma of a plus b. This is the value of the beta function in terms of the gamma function, correct? Now, this integrals again often show up a lot. So I can give you an example here. So let's say you want to find 0 to 1 x to the power 4, 1 minus x whole to the power 5 dx. Remember, this is nothing but the integral beta of 5 comma 6. Why am I writing 5 comma 6? Because you notice that a minus 1 and b minus 1 were there and not a and b. And beta of 5 comma 6 is nothing but gamma of 5, gamma of 6 by gamma of 5 plus 6. You evaluate this, you get 4 factorial, 5 factorial divided by 10 factorial. You can find out the value yourself. So yeah, a lot of integrals become very easy. The types of variants that you can use to evaluate this might also include something like this, that you have x to the power m minus 1 and then you have 1 minus x squared whole to the power n dx. Okay, let's just remove the 1 here. So x to the power m 1 minus x squared whole to the power n, right? So this does not conform to the pattern of beta functions, but you must be able to identify that if I substitute x squared equals to 1, notice that the limits do not change. So if you do t equals to x squared, you do actually get that, okay, dt is going to be 2x dx, right? Which means I can simply write this as x is nothing but root t, right? So I can write this as like this, 2 root t dx, or dx is dt by 2 root t. Therefore, the limits remain unchanged. X becomes t to the power half, so t to the power m by 2. This becomes 1 minus t whole to the power n, and dx becomes dt by 2 into t to the power minus half. And if you were to write it in form of a gamma of a beta function, you can simply write it as t to the power m plus 1 whole by 2 minus half, minus 1, I think, yes, minus 1. And then you can write 1 minus t whole to the power n plus 1 minus 1 dt. Now you see this is in the form of a beta function, and you can simply write the value as beta of m plus 1 by 2 comma n plus 1, and then there is a half outside. Now you can simplify it using gamma function. So yeah, these are also forms of the beta function that you must know. And what's important here is to understand this definition of how to write beta function in terms of gamma function. I'll try and bring some examples in the later videos, and sorry for this delay, of this huge delay that I had due to some problems, but yeah, you'll get a lot of other stuff very soon here. So thank you for watching, and if you're new to the channel, do subscribe.